Okay, so welcome to our webinar today, Tebis CAM Automation with Process Template Library. My name's Andrew Walters. I work with Tebis UK as an applications engineer. And today we're going to be having a look at pre-programming with templates. So, why do customers choose Tebis Template Automation? We're looking to standardize manufacturing process. We're going to build in a best practice into knowledge databases. We're going to share machining knowledge and experience. We're going to ensure machining quality and safety. We want to reduce CAM work pressure, relieve skill shortages, and reduce CNC and CAM work time and cost. So, Tebis Automation in general works with 5 basic databases. We have our virtual machines and clamping devices. This is our digital twin, set up to replicate your own personal machinery. We have cutting tools. Now, these are full-form tools, including tool holders and any intermediate holders, but also including all cutting conditions, so speeds, feeds, step over, step downs, even coolant condition. We have features, so we can have Tebis recognize geometric features within a component. And machining cycles, we can then link to features, and these are predefined machining processes that create canned cycles with intelligent tool selection. And lastly, we have machining processes, which is what we're going to be looking at today. This is basically our templating of machining programs. When we're doing the templating of machining programs, we're going to employ all of the other 4 database areas to create fully formed programs that are ready to use within Tebis. Now, with the machining processes, we can identify processing areas automatically, match machining processes, and intelligently select tools. When we have Tebis automatically selecting data, we can select this data by way of the color scheme, by way of layer information, but we can include variables and conditional statements for the intelligent selection of tools. The end outcome of all of this is that we have efficient, intelligent, and safe CNC programming. Now, if we're working with best practices within a company, it's all very well one engineer having access to this, but because Tebis works within a cloud environment or a server environment, we're able to spread that data and that knowledge throughout the company. So regardless of whether you're working within the same building or even in a completely different building, anywhere really, as long as we have access to the server and cloud data, we can have predefined processes that are used by every single programmer within the company. When we have standardized process like this, what we find is that when it gets to the shop floor, we have solid programs, we have efficient programs, and we have best quality that we can achieve. So what we're going to look at today is actually using the template to create some programs. So what we have on screen is a model of a clay car. So this model is actually something like 3 to 4 meters long. So it's a very big component. So in automated design, they create these clay models for the design process. And basically what we do is we machine over this model before they're hand finished. So effectively, what we want to do with a template is import a template. So we have a predefined machining process. So it takes care of the tool paths that are necessary to complete this job all in one operation. As a precursor to setting up the template, what we need to do is a little bit of CAD work in the background, just by way of an organization exercise. So what we want to do is have the template and Tebis do the programming, but we need to organize the data on screen so that Tebis can find it in the correct position. So as I touched on before, the template is going to read information from individual layers. So basically what we would do is take sections of the model. We could take sections of the model and split these up into individual layers. So this will be the roof section on layer 01 that we can see. This would be the side glass in layer 06. What you'll also notice as well is down in these corner, we have a series of axis systems. Now the green axis system is our datum for machining the actual part. The red axis systems are going to define tool direction. So when we come down the side of the car, we're going to need a tilt angle on this. So what we can see is the Z direction is going to denote the direction of the tool. Now this axis system is linked to the layer, as well as this surface data being also added to that layer. So not only can Tebis separate information by layer, we can also separate by color and by names as well. What we have here then is each of these individual areas up onto individual layers so that the template knows exactly where to find them. And then these axis systems are there so that Tebis knows how to machine them as well. Okay, all that should really be left to do is to actually import the template. Very simple minimum number of clicks. And what we have is a full machining process. So if we start at the start in the black layer, what we have included in the black layer is our virtual machine. So this is our digital twin. The virtual machine is set up so that we replicate exactly your machining environment. We include not just linear limits, but rotational limits, but also things like acceleration rate and board rate to give us the most accurate calculations possible. The next layer down now is where we can set the component within the virtual machine. This doubles up for collision checking as well. So if we have a look at this part, we can see the car is set up within the machine. So what I've actually done here is I've predefined a fixed position on the table that we would typically drop one of these car models onto. That way Tebis is able to automatically align the car components within the machine as well. So what we can also see is that the virtual machine includes all of the external guarding. This is in case you're using extra long tooling. There is sometimes a possibility that you can hit a guard with an extra long tool or maybe the back of the head. But with the collision checking and the fact that we have all of this data included, it means that we should be collision free. Tebis's virtual machine will also include off the machine movements, off the cut movements as well, like tool changing. Okay, so all that's really left to do is to calculate the toolpath. And that is as simple as hitting the play button. So this is just a confirmation screen to tell us that the data has been selected. We hit OK, and Tebis goes ahead and programs it. So basically what Tebis is doing is, by way of the definitions that we've already programmed into this toolpath, it's searching the layers, it's searching the relevant layers, it's cross-referencing that against the relevant colors, and cross-referencing that against the relevant axis system for tilt direction. This is enough information to be able to create the toolpath for each of the individual areas, for each of these individual toolpaths that we have here. Okay, what we will notice as well is that some of the areas, like the first area of machining, we've included more than one layer. So we're not limited to just saying pick information from here. We can choose absolutely which layers we want it chosen from. So this first operation actually chooses the front screen and the roof areas. So it's quite flexible in that we can choose exactly what area, what data we want. Similarly, although we're choosing from layers, we can sub-choose that then from colors. So if we have more than one set of information on a layer, we can distinguish between the two. So as I say, this is our toolpath for the top machining. Now, whilst this yellow area is the roof and the front is the front screen and bonnet, it's actually included it as a single operation. So as we can see from this, it's a very simple 3-axis toolpath. What you will see as well is safety positions that are also pre-programmed into the process. So as we go along, we can see that the toolpath is a simple 3-axis toolpath done in the vertical tool direction. As we come down the toolpaths, we can now see that we've got some angles being included, or some tilt direction being included. And what we have now is the head over at 90 degrees to be able to create the toolpath to fully encompass the front bumper section. Okay, so if we do the entire program, what we can see is that At the start and end of each program, we have a nice safety position, and this allows the head to turn to the next position nice and cleanly off the part. This way, we've got no collisions while we're down on the component. Sometimes in some systems, we can have a situation where we're machining from one direction, we go to rotate the head, we don't have enough clearance, and we can drive the head straight into the part. Because these processes are all predefined and proven out previously, we know that Tebis is going to handle this correctly, and we should have a full collision-free process. Okay, so to make the Tebis template, select the right areas. What we've done is within the element section where we would normally choose the component surfaces, instead of choosing individual surfaces like you would do in a conventional toolpath, what we've done is we've created a filter. And what this filter will do is it could define these surfaces by these different constraints. So we could choose any of these types of elements to surface machine across. We could choose them from any of these layers. We can then cross-reference against colors. We could even add names to individual elements, so it will only machine those singular elements. So with a combination of this between the component surfaces, protected surfaces for fixturing and such like, we're able to create a very concise, very efficient program. So whilst we're in this machining environment, what will quite happen, or is certainly familiar to most machinists, is we either have a machine breakdown, or there's the possibility the machines become overloaded or fallen behind on schedule. We want to change the machine that we're working on. One of the big flexibilities with Tebis in this templating environment is that we can change any specific set of parameters and it will just update and carry on machining. So in this instance, we want to change the machine. So we can switch this machine to any other machine as long as it works with the types of toolpaths that we're using. What we don't want to do is choose a 3-axis machine when we're doing 5-axis toolpaths. But other than the obvious constraints of the mechanics, we should be able to change this machine, and Tebis will just recalculate the toolpaths and just carry on. Fully collision checked, fully safe, and working within the predefined parameters of the program. Also, because Tebis, once this template is imported, these templates aren't as rigid as some operators. So some software providers will provide templates, but they're very rigid. They're not flexible. You can't change any of the data. As far as Tebis is concerned, this is just a program now. We brought it in as a template. It's a predefined machining process, but we're flexible enough that we can change this at any point. For example, if we were to change this tool from a 32mm diameter ball nose to a 36mm diameter ball nose, necessarily this will change step overs, step downs, speeds and feeds. Because Tebis interactively works with the tooling library, and the tooling library holds all of this information in itself, if we were to change this tool now, we would see a change in the step down, a change in the step overs, and a change in the speeds and feeds as well. So that way we're super flexible and able to make modifications for the odd pieces of data or changing tooling whenever it's necessary. Okay, so if we have a look at a slightly different kind of part. So what we have now is we'll go through a similar sort of process, but we've got different organization in the layer tree, but the templating will work exactly the same. So on this particular part, we have the component on the top in blue, and we have the fixture underneath. And what we're going to do is we're going to machine the fixture face to allow our trimmed component there to mount onto the face properly. So instead of organizing into individual layers like we did last time, or breaking the model down into separate areas like we did last time, what we can do is allow the Tebis template to make more of the interactive choices about how we machine, and we're going to keep all of the machining surfaces in one area. This time, however, we have included a stock model. This is because, unlike the clay part where we have a laid up amount of material on the outside, this part is coming from a block of material. We've also got some support elements. So these are some hole caps. Now, this is just general machining strategy. These will have to be created to cover the holes, but it allows a nice, clean, smooth cut when it's surface machines over the outside. What we also have is Tebis has extracted some feature geometry from within the component. Now, when we extract feature geometry like this, it can be connected to what we call an NC set, and that will create a predefined machining process for that one particular feature. Now, that will include interactive choice of tools, and we'll have a look at that when we apply the template. Okay, so exactly the same process as before. We're going to right click, import the new template. Okay, so as before, we've predefined the machine. We've already set the part up in the machine because the template takes care of that. And all we should really need to do is hit the calculate button. So what we'll see happening in this particular program now is as the toolpaths come up, the first roughing operation is a full Z level roughing. So what that'll do is it'll take all of the excess material out of the predefined block. As we come on to the next path down and see the re-roughing, we'll see a much smaller amount of material being taken out. And that's because Tebis interactively checks the volume of material that's left and will only cut in areas where there's material to take. This means we can reduce a lot of unwanted machine time, fresh air machining. We can make the toolpath in the second roughing areas a lot faster and a lot more efficient. So as we come down then, we've got our steep areas finishing. So this will be surface cutting down the steep areas of the component. We then have the shallow areas machining, which will be coming up next. And this covers the large surface areas, all in the predominantly shallow areas. The next two areas down then are residual fillet machining. These will come back and they will take out any small corners that haven't already been taken by the surface machining. And the last area then is the holes. Once it's calculated out, we'll have a good look at that. And what they'll be doing is it will choose a number of tools depending on the hole features. It will choose a spot drill, a drill and an end mill, and create multiple programs all within the single operation. Okay, so that's calculated. If we have a look at the roughing operation, as you can see, we've got the step downs and step overs. And again, if we were to change the tool, it would adjust all of the step overs and step downs and speeds and feeds to accommodate that. In the re-roughing area, a much smaller amount of toolpath because, as I say, Tebis is only machining in the areas where there's volumes of stock to take out. What's a nice feature in Tebis is if we come down to the steep area of machining, quite often we'll be doing fillet machining, especially in these vertical type of areas. And what will happen is we'll run out of tool length. Now, Tebis is set up in this instance to automatically create a 5-axis collision avoidance program. So what we've got here is as the tool comes in, it'll start vertical and then it'll tip the head over and pull the tool holder away from the component, allowing for tool clearance so we don't have any collisions. Now, even though that's quite a complex operation, that's all taken care of in the template, and the parameters within the template has told Tebis where it needs to avoid, how it needs to avoid, and automatically done all the avoidance for us. Okay, so lastly to see is our feature set. So right at the very beginning in our data organization, we extracted some features and it recognized the features, assigned the relevant NC set. Now, what Tebis will do from here in, it will make interactive choices for us. So depending on the size of the hole, depending on the size of the counterbore, it will choose the correct tool to machine the correct feature. So as we watch the program run through, what we can see here is the spot drill. So the spot drill seems to be a fairly small one, something like a 6 mil. And that's the relevant size for the type of hole that we're creating. So it's gone around, it's done the spotting. All of this is taken up within a single operation that we saw. It's now doing the drilling that it needs to do to create the hole feature. And one thing to also bear in mind, because we're all within a singular machining operation, even though this is multiple programs, all of the connections between the tool paths are all fully collision checked. Therefore, we're not just checking on the job like most softwares will do. We're actually checking the toolpath off of the job to ensure that we've got no collision going on whilst we're moving between operations. As I'm sure you can appreciate, if we go from this hole here to this hole here, as we've just seen, it'd be very easy to go through the component. Because Tebis has done this all in a feature set, it knows to go around the component and automatically avoids the part so as not to create a collision. Okay, so in the broad strokes, once we have this technology in place and once we understand the processes that we're using, we've reduced programming the complete part to an organizational exercise within our layer tree. So we split our data up into layers, possibly color coded to allow the template to find the correct data. And all we've done is we've imported the template and let Tebis do the programming. As you can see, programming that part took all of 4 or 5 minutes. Okay, so in summary, we're looking to standardize manufacturing process. If we implement these templates, we can have everybody using the same template. That way, we're using the same tools, we're using the same speeds and feeds, we're creating the same quality, and we're programming in the same time. Now, with Tebis being able to cross-reference things like tools and stuff against virtual machine, against material, it means that our process is absolutely standardized across the board. We're building in best practice into the knowledge database. So if we have a high-level engineer who's designing process, he's got the on-machine knowledge, he's got the experience with the machines, the experience with the materials. He could design these processes and have them set up. That way, anyone has access to them. We're sharing machine knowledge and experience. So again, when people have experience within a certain sphere, we're able to create these templates, and that allows other people to be able to use them. That means we have other people without necessarily the innate knowledge, but are then able to output at the same level as the original machinist. We're ensuring quality and safety. If we're using the same program every time, we know what the quality is going to be. If we're using the same process all the time, then we know that the safety is there because it's been proven, it's been used before. We can reduce CAM work pressure. Now, what quite often happens in companies, we'll go through the organizational process that we just did because that's just sensible machining, but then we have to write a program from scratch. So why spend 4, 5, 6 hours, maybe even a day or two writing a program when we can employ a template and have the program set out, calculated and ready to go in minutes. We can relieve skill shortages. Now, everything we've talked about so far has been with the aim of creating safe, consistent programs quickly, effectively and efficiently. But there's also a secondary benefit to this. What we can have is if we have a skill shortage within a working environment, so if we have someone leave or we have someone retire, or possibly having someone new coming into the company or even an apprentice moving up, if we have an experienced engineer creating these templates, then these templates are there and available for the other people to use. This shortens learning time. So the learning curve can be very much shortened because the experience and the familiarity with Tebis is being created by using the templates. So the ultimate for any CAM process, we're going to reduce CNC and CAM work time and cost. So if we can make parts quicker, more effectively, and still guarantee quality and safety, everyone wins. It's absolutely the best way to go, and it's the way that companies need to work. So I hope you guys have seen some stuff that you quite like within that demonstration. If you have, please feel free to log on to tebis.com. Alternatively, contact us directly at Tebis UK or Tebis USA with the details provided on the screen. So thank you very much for listening to me. And that's the end of the demonstration. And stay safe. Thank you, guys.